This is a little video that I'm putting together for about the inverse normal distribution and how to use it in a practical manner. Now, this material is suited a little bit more for the Beoga material that I'm teaching from right now, and the ways in which that it is suited more to the Beoga material I could explain, but I think I'm just going to leave that for the people who are using Beoga alone. So first of all, we're going to do an example where we're going to find two z-values that separate the middle from the upper 0.5% and the lower 0.5%. Now what this means visually is that we're going to be looking at here and here as cutoffs, and we're saying that there's this 0.05% or 0.5% here, which is 0.005. And there's this 0.005 over here in the lower tail as well. So we're separating the lower 0.5% and the upper 0.5%, which I've changed to decimals, from the middle percentage. Now, if you remember, the entire curve here is 100%. So if we have 100%, and we're taking away 0.5% and another 0.5%. This tells us that we have 1 whole percent here, so 100 minus 1 whole percent, which is 99% left. And that 99% is right here in the middle. And I'll write it again as a decimal, 0.99. So what we're trying to find here is the z-value that's down here and the z-value that's up here that put exactly 0.99 in the middle, or another way of looking at it is putting 0.005 in the left tail or putting 0.005 in the right tail. Now all of these different ways of looking at it, relating the areas in the left tail and the right tail or the middle of the distribution, are very, very important to understand. Now the other thing that we need to understand is that we are finding the z-values, the values from the standard normal distribution that will place these particular ones. I also want you to note that I have chosen a symmetric interval here. So this z-value here I've represented with a negative, and this one I've represented as a positive, and I've just represented them as z's because they are the exact same values. One's just negative and one's positive. And we're going to use that in our process of finding these z-values. So there are three different ways in which I can find these z-values that I desire. Now what I want to do first of all here is I want to make a little bit of a notation of what I'm doing. I'm going to be finding the probability that a z-value is less than some negative z-value is equal to that area in my left tail. If you remember right, the z-tables are only made to look at this area in the left tail, this 0.05. Now, if you remember right also from the picture that I drew on the other side, this 0.05 005 is also in this upper tail. So this is actually equivalent to the probability that z is greater than a z value is equal to 0.005 as well. So when I'm finding this one, because it's a negative down here, I'm also finding this one up here because it's the same value, it's just the positive of whatever this value is. Now also, when I'm finding these two values, I'm actually finding the two values that put the complement of the tails into the middle of the distribution. So those are three different ways of looking at that. Now, no matter if you're using a z-table or your calculator, all of these things are using this idea that there is area in the left tail. So if I want to do this in my z-table, I'm going to go to my z-table, and I've got one written right or brought up right here. And in the body of the table, which shows you probabilities, and that is what we're looking at, area under the curve is a probability, we're going to find 0.005, or as close as we can possibly get to 0.005. Now you'll notice here that these are very small probabilities up here. So I'm starting to look from the beginning, and I'm coming across here and I'm seeing 0.0037, 0.0073. Oops, I've gone too far. Oh, here's more my line here, 0.0055, 0.0052, 0.0051, 0.0049. Darn it. I've missed it somewhere in between here. So what we could do is we could get the average of these two, and from the z-table, that's exactly what we'd do, and we'd say, oh, it's halfway between or between -2, 5, and this one comes from 7, and 2, 5, and this one is 0.08. So it's halfway between these two values on my table. So halfway between -2.57 and -2.58. And therefore, the table value that most people would get would be the average of these, and the average would be -2.575, halfway between. Now you'll notice that my z-table here has a little bit of a star right here, and if we followed that down, you would see that it gives you exactly that value. So this is kind of a special table in that it has that star. In the Beoga material, we're going to be using not the 3 decimal value for this, but instead we're going to be using a 2 decimal value. So in Beoga, we're just going to use -2.58. We're going to use it rounded to that second decimal, or to the hundredths place. So that's what our value is here. Now remember, I said that this is my negative z-value, so my positive z-value would be 2.58. Now, if I were going to look up the 2.58 in my table, remember what I'd really want to be looking up here is the area to the right of this. So what's to the right of this value? Well, to the right of this value is the complement of what's over here in this tail. So what I've drawn in here in black is 1 minus 0.005, or this is 0.995. And so if we go over here, we also have a positive z-table, and this positive z-table here, if I'm looking for 0.995, so here's 994, 9946, 9948, 9949, and 9951. So again, we see it's halfway in between here, and what I've got is 2.5 and 7 and 2.5 and then 8. So again, we do see exactly this value as we expected to see it based upon the positive z-table. Now I'm going to also show you something called a t-table. Eventually we're going to get to this anyway, so I love the t-table because the t-table gives me some very quick ways of finding these. Now the z-table is based a little bit differently than a z-table. It is actually giving you what we call critical values. That's the actual z-score. Based upon some very specific requirements for areas in the tail. So what I'm looking for is an area in one tail here. So let me get out my highlighter. Area in one tail here to be 0.005. So let me go here and say that the area in one tail is 0.005. So I'm going to go over here and I'm going to see area in one tail right here. And I'm going to go find the one that says 0.005. Now the t-table also has something different. It has this degrees of freedom thing. Now degrees of freedom for what I'm using are just really they're more information than I need, because the t distribution actually has these things called degrees of freedom. We'll study it soon, so don't worry about it if you don't know what it is. But the thing is that a t distribution is when the degrees of freedom are infinite or very, very large, the same as a normal distribution, and that's what I'm going to use. So I'm going to find this 0.05, and then I'm going to go to the bottom of the t distribution here, and the degrees of freedom over here, it says large. Whenever the degrees of freedom are large, not any of these others, mind you, just this one, the large one, that I'm looking at a z-score. These are all z-values. So this was my 0.0051, and notice that value, rounded to 2 decimal places, is the one I'm wanting. So this is 2.576, and therefore it's approximately 2.58. Exactly what we got before. Now something else that you notice, that the table gives you positive values, right? This is a positive value. So you're looking at this side, and you know this time around that the other side is the negative value, negative 2.58. So this one works positive, then you get the negative, where here I went from the negative and then got the positive. Okay, our last one is to use the TI calculator. To do this with the TI calculator, I'm still going to be looking at the left tail area. So if I'm looking at the left tail area, I'm going to be saying that this is 0.005, or if I want the positive value, then I would say that I want the complement of 0.005, so 1 minus 0.005, and that's going to give me the 0.995. So now what I have to do is I go to my distributions menu, and I get this with the second function of the variable key. So second function and then the variable key, and then I go down to the inverse normal, and then I do an enter, and depending upon the calculator that you have, you may either get this in your screen, or you may get a whole list of information, and the list of information that you get would be the area, and then it would be the mean and standard deviation. And if you haven't messed with this before, this mean is already 0 and the standard deviation is already 1, and then you just have to do a, what does it say? It says input or something like this here. So at any rate, what you're going to put in here is 0.005, and what this will then, after you return, output will be your big old long decimal of negative 2.57, and then this is going to be 5, and then there's going to be a bunch of decimals, which this one will round to a 6 if you're rounding it to a 3, and if we're rounding it to 2, which is where our Beoga does, it doesn't really matter what these are, this will round to an 8. So we'll get the same 3 values consistently throughout. And that is how we're going to find those z-values using the inverse normal. All right, that's going to wrap up this particular video right now.